The whole universe was in a hot, dense state. Then nearly 14 billion years ago, expansion started. We don't know what happened before then. But after a little less than 400,000 years of expansion, the universe had cooled down to a temperature of a few thousand degrees and become transparent to light. We can, using our astronomical instruments, look back to these ancient times and study the cosmic microwave background radiation. At that time, when light lost its grip on matter, galaxies started to form. But it's only 5% of the energy in our universe which is in the form of ordinary matter, like stars and planets and living beings. 26% is in the form of the mysterious dark matter. 69% is the dark energy that forces the galaxies to move away from each other ever faster. We are living towards the end of the era of the galaxies. Over the next several billion of years of expansion, our universe will turn into a darker and lonelier place. One can compare our universe to a cup of coffee. Most of it is, of course, coffee. This is the dark energy. Then a fair amount of cream. This is the dark matter. And then just a tiny little bit of sugar. This is the ordinary matter. This is what science has been all about for thousands of years.
Thank you.
Up until now. This is the picture of our universe. Looking back almost 14 billion years in time, this is the cosmic microwave background radiation. Already at the time of its discovery, in the mid-1960s, James Peebles realized the importance of cosmic radiation. Over the next 2 decades, he developed new theoretical tools and used them to uncover the dark components of our universe. Through his work and new ways to observe and measure our universe, cosmology evolved into a science of precision. Science of precision based on the mathematical foundation. Cosmology matured into physical cosmology. Michel Mayor and Didier Queloz focused on what is most important to us, the sugar in the cup. They awarded the Nobel Prize in Physics for the discovery of a planet in orbit around another sun. They studied an anonymous star 50 light years away, visible to the naked eye under dark and clear skies, in the constellation of Pegasus, the flying horse. They couldn't see the planet directly, so they had to use other methods. When a planet is orbiting a star, the star wobbles back and forth. In the same way as the sound of an approaching train changes its pitch when the train moves towards us and then away, there is a subtle change in the color of the star. As the star moves towards you, the light gets a little bit bluer. When the star moves away, the color is shifted towards the red. The effect is tiny, and you need care and ingenuity if you want to detect it. This is the result. This is the discovery of the first planet in orbit around a solar-type star other than the Sun. The planet had unexpected properties. It was so close to its sun that its year lasted no more than a few Earth days. Its temperature was 1,000 degrees, and it was as big as Jupiter. few had expected that such planets could exist. We had thought that other solar systems would be similar to our own. We were wrong. We now know there are many different kinds of planetary systems. In our own galaxy, our own Milky Way, there might be billions of planets. Some of them might be similar to our own Earth. Through the study of these exoplanets, we will learn more about the physics of how planets form and evolve and get a new perspective on our planetary home. This year's Nobel laureates in physics have painted a picture of a universe far stranger and more wonderful than we ever could have imagined. Our view of our place in the universe will never be the same again.
Thank you, Ulf.